Now, in a context of international trade, so when both economies are open, we are going to have two exercises here quite similar, so that's why we're going to do it together. Exercise 6 and 7. In the exercise 6, we have this information. So we have the economy 1 and the economy 2. We have the information about the opportunity cost of producing 1 unit more of cars in each economy. So in the case of cars, it's 0.5 computers. So if you want to produce 1 car more, you need to reduce your production of computers in half units. And here you have the same kind of information, but for the case of the foreign economy. The question is, okay, that was the opportunity cost in each economy, but what is going to be the relative price when these two economies start to trade? So the new relative price in international terms. So we also know that that relative prices before of trade openness are going to be in this way. So we know that the opportunity cost of car is also the relative price of cars, and that is for the home economy, and the same thing for the foreign economy. So we have in fact the pre-trade relative prices. In fact, in this case, is the relative price of car. So we know that international trade is going to mean that the relative price of car is not going to be so small, neither so big. It's going to be something in between. How is that? Because workers here are going to be really happy selling to that economy, because this economy is willing to buy those cars always that the price is smaller than free. And we have like a rank, like a rank of value, or an interval of value between those two extreme cases. So this economy is going to start to sell cars to this economy. People from here are going to have a lower supply of cars inside of the economy, so they are going to pay more than 0.5, and these people is going to pay less than free. So that's why the relative price of car is going to be between those two values. With that information, with that in mind, we can answer. We don't have information to know what is going to be the exactly value, but which one of these that we have can be. A is not possible because A is this value. We know that it has to be between these two cases. B is the right answer because it's 0.75. It's a value between these two values. C is not possible because it's below than this value, and D is higher than this value. So now we know that the relative price can be, the relative price of car can be 0.75. And what about, and that is the next question, what about the relative price of computers? Well, if I know that this is the relative price of car at home and this is foreign, the relative price of computer is just inverse, okay? So here we have 2. Remember, this 2 is the number of cars that I can buy per unit of computer, or I can exchange. And here we have the same kind of information, but for the case of the foreign economy with a different value, of course. So, which of the following relative price could be the international relative price of computer? As I said, it has to be a value between these two values. How is that? Because you see that here the relative price of computer is quite big in comparison with this value, so people from here is willing to pay more than 0.35 because they are paying already 2 units. Okay, so that's why these people is going to start to buy from here, and these suppliers of computer are going to start to put higher prices. So eventually the new and unique international relative price of computer is going to be between those two values. And that is just possible for the answer A, which is 1.5, okay? The others are 2, which is not possible, or this value, or higher than this value, which is not possible neither. And that is the answer then. About the question 8 and 9 also are connected with this previous question. That's why I'm going to continue here. The question 8 is asking us what could be the opportunity cost for the economy too, so for the foreign economy, to produce one computer. That, as we said previously, the opportunity cost also is equal to the relative price of computer in this case. So the right answer is this value. The next question, question number 8, which of the two economies has an absolute advantage in the production of both goods or in its goods? Here the right answer is that we need more information to answer this question. In fact, we need more information about the unit labor requirement, or at least the marginal product of labor, because here we just have the final result of the unit labor requirement of car divided unit labor requirement of computer, but we don't have the absolute values of that unit labor requirement. So we are just observing the relative terms. So we just can be able to see the comparative advantage, so in relative terms. But we need more information about that thing that is connected with technology. So I mean unit labor requirement, or at least marginal products of labor in each sector for each economy. We don't have that, so we can answer about absolute advantage. Now we are going to do the question 10 and 11. Both of them are connected. So we have in the question 10 two economies, home economy and the foreign economy. Also we have the unit labor requirement in each sector, because we have the number of units that we need for the production of the number of units of labor that we need to get 1 unit of orange and 1 unit of apple in the home economy and in the foreign economy. Okay, so given that information, after trade openness, the answer that is right, C, we should expect that the salary will be higher in home because that economy has an absolute advantage in its goods. In fact, you can see that this value is smaller than this value, so in the orange sector, this economy, given its technology, it just needs 1 labor, where the other economy needs 2 units of labor. So here we have a better technology. The same thing with the apple sector. 2 is smaller than 3, so we can say also that this economy has an absolute advantage in the production of apples. And we know from the theory that if we have an economy with an absolute advantage in both goods, by sure the weight in that economy is going to be higher than in the other economy. Because wages are coming from marginal productivity, which is the inverse of this value. So as smaller is this value, higher is the marginal productivity, and also is going to be determined by prices. And with international trade, prices are going to, well, in one case it's going to increase and in the other good it's going to decrease. But eventually we know from the theory that this is the economy that is going to have the higher salary or wage, as you prefer. So that is coming from the question 10. Let me tell you why it's not right the others. Okay? A, the salary in both economies will be the same. No. We know that inside of an economy the wage is equal across both sectors. But we don't have enough information to know how it's going to be the wage of one economy versus to the other economy. We just know that when one economy has an absolute advantage in both goods, by sure there is going to be the higher wages or the higher wage or the higher salary, okay? But it's the only thing that we know. And by sure, it doesn't have to be equal, the wage of the salary or wage in one economy to the other. B, the salary will be higher in home because it has a comparative advantage in the production of orange that is better than for the foreign economy in the case of apple. even in that case, we don't know how it's going to be the weight in its economy. So we can say that. It's not because that, okay? There are more factors behind. D, which is not right neither. We can know because we need more information on relative prices. As I said, we don't need more information. The key here is the absolute advance in that home economy for the both goods. Now let's go to the exercise 11, which is connected with this one. So it's taking that information in mind. We know that, and the answer that is right is A. Home is going to specialize in the production of orange. Why is that? Well, we know that even in the case that an economy has an absolute advantage in both goods, we are going to find trade. In fact, we are going to see in this Ricardian model that each economy is going to specialize in the production of one specific good. So each economy is going to produce just one good, and then it's going to trade with the other economy. To know how it's going to work in this context in which home is the best doing everything, we need, by sure, the comparative advantage. To see that, we need the opportunity cost, okay, of producing orange or apples. It doesn't matter, sorry. So here we have the opportunity cost, for example, of producing 1 unit more of orange. That is the unit labor requirement of orange divided by the unit labor requirement of apples. This is for the home economy, and this is for the foreign economy. The inverse value is going to be the opportunity cost of 1 apple. Okay. So if I'm doing this analysis in an indirect way, I'm doing the other. Okay. So here we have that we know that this value is smaller than this value. So that means that this economy has a comparative advantage in the production of orange. So that means that that economy is going to specialize in the production of orange. That is the answer. A is for B because it's telling us that home is going to produce everything. So orange and apple is not true, like D, but in that case it's for the case of the foreign economy. Neither is true. Or C, where it's telling us that for the foreign economy is going to specialize in the production of orange. We know that that is going to be home. By sure, the foreign economy is going to specialize in the production of apples instead. Now we are going to answer the exercise 12, sorry, the 11 was done, yes, 12. So here we have two economies, home and foreign. We have the marginal productivity of labor for each sector and in each economy. What is the inverse, if you remember, to the unit labor requirement? So if we have that for the whole economy, the marginal product of labor in the case of car, in that industry, is equal to 0.5, that is also equal to the inverse of the unit labor requirement of car in that economy, okay? And that is for all the cases. So here we have the marginal product of labor at home in the case of computer, and here for the foreign economy, cars versus labor. So it's given that information, we have to say which one of the following statements is the right one. And the right answer is B, where B is telling us that both B and C are correct. Let's see B and C. B, foreign economy has an absolute advantage in the production of cars and computers. That is right, because, well, keep in mind that this is productivity, so as higher is the value, better. So we can see that the foreign economy in the car industry, the marginal productivity of labor is 1, which is higher than 0.5, that is for the home economy. And in the case of the computer sector is 3, which is higher, so it's better than in the home economy, which is just 2. So we can see that in both sectors, foreign has an absolute advantage, so that is right. Foreign is going to specialize in the production of cars in the states of computers. So we should expect then that the comparative advantage in the case of the foreign economy is going to be in the car industry. So the opportunity cost of producing 1 unit more of car is smaller in that economy than in the foreign economy. So let's do then the opportunity cost of producing 1 unit more of cars, both at home and at the foreign economy. We know that that is unit labor requirement of car divided by unit labor requirement of computer in its case. Here we have the inverse value, okay? But we also know that if the marginal productivity of labor of car is 1 over unit labor requirement, we can isolate this term. So here is dividing, so goes to the other side of the expression multiplying, while the marginal product of labor, which is here multiplying, goes dividing. So we have this for the home economy. For its sector, the same thing is going to be for the foreign economy. So you can write also that part. So we can see that instead of this, we can introduce that, which is 1 over marginal product of labor in the car industry over 1 over marginal product of labor in the computer industry. You can see that this is a division of two coefficients, so it's this times this divided this value times this. So the thing that we are going to always have is that if the opportunity cost of car is unit labor requirement of car divided the unit labor requirement of computer, so of the other goods, in terms of marginal productivity, it's just going to be the opposite, the inverse. Given the fact that the marginal productivity is the inverse of the unit labor requirement. So we are going to have that here is going to be marginal products of labor of computer divided marginal products of labor of car. This is for the home industry, but the same thing we are going to have for the foreign industry. In fact, we have this value, so it's going to be really easy. Computer is here is 2, okay? 2 over 0.5, and here is going to be 3 over 1. So this is equal to 3, while this is equal to 4. So the lower opportunity cost in producing car is in the foreign economy, so that is the economy that is going to specialize in the production of cars. Now we are going to the problem section. The first exercise is telling us about one economy with 50 units of labor. Also, we know that this economy is able to produce two goods, the good X and the good Y, and also we have information about the production function. So that means the equation when we have the number of units that we are going to be able to produce given our unique production factor, which is labor. This is for the case of X and this is for the case of the good Y. So the meaning of that is per unit of labor that I put in that sector, I'm going to get 10 units of that good. In the case of the good Y, it's a little bit more complicated because it has this, but in fact the meaning of that is per unit that I introduce here of labor, I'm going to increase into the production of the good Y, okay? But, well, that is not the question. The question is, okay, given or imagine a situation in which the production of X is equal to 100, while the production of Y is equal to 85 units. So, that is possible. Well, it is going to be possible always that the number of labor that you are using to produce each unit, the total number of labor is smaller or equal to the total labor. If we need more labor than the actual labor we have in that economy, it's not possible. So let's go back to the production function. Let's put the production in its case and see the number of workers that we need to produce those amounts, okay? So if the production of X is equal to 100, so we have 100 is equal to 10 times labor that is used in that sector. So this is multiplying, goes to the other side divided, so the number of workers that we need is just 10. Let's see what's going on when we are producing 85 units of Y. So is the same expression, but now here we have the production of y. The number 5 is with a positive sign, so goes to the other side with a negative sign. Here we have number 2, which is multiplying, so goes to the other side dividing. So finally, the total labor that we need is 80/2, so it's 40. If you sum 10 plus 40 is 50, so it's possible, and in fact it's efficient, because if you are producing that combination of quantities, you are using all your resources, all the labor that you have, so it's efficient. You are in the PPF curve. Now in the exercise 2, we have a company, I think, a firm that is able to produce two kinds of goods, cell phones and laptops. The thing is, if if these firms use the resources in just producing, for instance, cell phones, so the production is 0, the maximum amount of cell phones is 8. Okay, so here we have all the possible, or some of the possible combination in the production of the two goods, given the resources that this firm has. So here, given the labor that this company has. The question here in this context, where we have different possible combinations, is what is the opportunity cost of producing 1 unit more of cell phone? We know also that the production functions are linear. So in fact, this is telling me that the opportunity cost, which is graphically is the slope, or it can be the inverse of the slope, doesn't matter, of that PPF is constant, okay? And that is really important. Why is that? Because if it's constant, I can see the opportunity cost, I mean the slope, considering any combination of the two points that I choose, okay? So I can choose these 2 points or the string cases, it doesn't matter. The slope is the same, so for any two possible combinations of the points of production, I can get the slope, okay? In fact, the question here is about the cell phone, but the really easy things to do is getting the opposite. What I'm telling you, the thing that I'm telling you is you see this table, you have here when the production of laptops is 0, and you see what's going on when you increase in 1 unit the production of laptops. In fact, you can see that if you produce 1 laptop more, you are going to reduce, which is the opportunity cost of producing 1 laptop more, you're going to reduce in 2 units the cell phones. Of course, that is going to happen always, because as we said, the production functions are linear. So we have that information, and we can use, in fact, that information. So the opportunity cost of producing 1 laptop more is always 2. So, by sure, the opportunity cost of producing 1 cell phone is going to be just inverse, 1/2. But even in the case that you don't see that, you can get the actual opportunity cost of producing 1 cell phone instead of getting the other opportunity cost and then do the inverse value. How is the way of getting that? Well, you can choose any 2 points or combinations and then try to evaluate how does it change the laptop production when you increase in 1 unit the cell phone. The problem in the case of cell phone is that we have increased not in 1 unit but in 2. You see, here you are producing 2 cell phones, but here you are producing 4 instead of just 3. I mean, instead of just 1 more. But it doesn't matter. The thing that you can do is, okay, let's see how change the total number of laptop from, I'm going to take this and this point, okay? You can choose 2 of them. Doesn't matter, this and this, this and this, and this and this. The results always is going to be the same. So, how is going to change laptop? Okay? When you change cell phone. Okay? So, you are going to have them, because it's a division, you are going to have how does it change the number of laptops per unit of change in the case of cell phone. As I said, I'm going to consider this, and I'm going to put that change in absolute terms as usual. Let me continue here. So the variation of laptops is, I'm going to from this point to this point. Why? Because here I am observing the effect of increasing cell phone, and that is the opportunity cost of producing 1 unit more, so produce more. From 2 to 4 you are producing more cell phones. What's going on in the case of laptop? Well, final value 2 minus initial value 3. As you are going to use always the absolute terms, you can see that in fact it doesn't matter if you do final value minus initial and vice versa. But theoretically it's much better always put final value minus initial value. The same thing for the case of cell phone. So we were producing 2 units, but now we are producing 4, final minus initial. So here we have, because it's in absolute terms, forget about the minus, we have 1 over 2, of course, is the same value as the one that we were expected. Now we are going to answer the exercise 3. I have to confess that this exercise that is just about opportunity cost or, well, accounting cost, it can be a little bit tricky. But let's see the information that we have. Imagine that you are in this situation. You can, in one specific day, go to your driving lessons, or also you have an alternative plan, which is going to a basketball game. We also now know that if you want to go to your driving lesson, you don't have to pay anything about or in terms of transportation or something like that. But if you want to go to the basketball game, you have to pay the ticket, and also you have to pay something for transport. So you have a transport cost. Additionally, also we have like an information about your satisfaction of each activity or your happiness, you can say. So if you're going to your driving lesson, you're going to feel like good because you're doing the right thing, you want to pass the exam, and then you're going to give to that activity 18 units of happiness or satisfaction. Okay? While in the case of basketball, it's something that you really enjoy going there and watching that value gain in happiness is 40 units. Okay, in that context we have the next question. We have on one side the first question A, which is about the accounting cost or the explicit cost. When we are talking about accounting cost, it's without thinking about opportunity. Okay, it's just the money that you have to spend to do or to get something. Spend on something. In the driving lesson, that explicit cost is 0 because, as we said, here we don't have to pay anything to get that driving lesson. Even transportation is free. Imagine that you are living in United States and it's your mom or your dad the one that is giving you that lesson. In the case of basketball, is the ticket plus the transport cost. So in total, this is 22. Okay, we are going to have that number more ahead again. The next question is about the opportunity cost in the case of driving lessons. Where is that? So the opportunity cost is what you are giving up when you are doing something. In this case, you are using your time in your driving lessons. So that opportunity cost, the thing that you are giving up, is going to the basketball. In that case, that happiness that you are not going to enjoy is a cost, okay? Also, it's true that you are going to save money because you are not going to spend your money in the ticket or in the transport cost, in the transportation. So finally, the opportunity cost is not so high, but it's positive and it is equal to 80. Okay, so it's the cost minus the saving. You are saving money in the way that you are not using that money in that activity. So the opportunity cost, though is positive, is not so high as in the case in which you have a free ticket, so you don't have to pay, someone gives you the ticket and the cost of transportation is zero. And what about the opportunity cost when you are going to the basketball? Well, here the cost of going there is going to be that you are going to feel like guilty. You were happy doing your lesson, your driving lesson. In fact, that happiness, it was 18 units of happiness, or you can quantify that in monetary terms, it's like 18 euros. That is the cost that for sure you are going to suffer. But also it's true that you have an additional cost, because when you are going to the basketball you have to spend your money, and you could use that money in a different thing. So the opportunity cost is not just this, it's also all the things that you are not going to buy because you are using that money in the ticket and in the transportation. So the actual opportunity cost of basketball, of going there, is that satisfaction that you are giving up plus the money that you are using, and you can use that money in a different alternative. So that's why it's 40. Now we're going to do the exercise 4. We have here two economies or kingdom. One of them is the King's Landing. Okay, I'm going to use the gate for indicate that. Okay, and also we are going to have, let me see, the other kingdom, which is the Volantis. Okay, I'm going to use the Q. This, okay. Also, we know that these two economies are able to produce two kinds of goods: helmets and swords. Okay. Also, we have information about the production function. In fact, in its case, we have the same kind of a production function, which is in terms of helmets. Okay. So the thing that you actually have is this function and this function. Then what is this? Well, this is coming from here. I have to confess that I like to have always the production function where in its case, so in two cases, in its case is isolated one of the goods that it can be done, it can be produced. Okay? So just keep in mind that PPF, because that also is not exactly the production function, it's more related to the PPF curve. Because here we are connecting both goods, and by sure this must be labor, okay? It should be labor behind that. So the thing that we actually have is how to produce more helmets, you need to produce less swords, okay? You see there's the negative relation between these two variables, okay? I was just observing if the how is said this? Yeah, it's the PPF, okay? It's not the production function. That was a mistake of me. And I am observing that is the PPF. So, as I said, I like to have the PPF where one of the goods is isolated, but also the other. Why? Because that is going to make my life easier when I have to make a graph. Okay? In fact, here, as I told you, that was the initial PPF that the exercise is giving me, but now I have when the other good is isolated. This is for the king economy, this is for the other economy, okay? But it's the same thing. The exercise, the section A is asking me about the PPF, so I have to draw that PPF. And also, I have to say if any economy have an absolute advantage in the production of a specific good or both or whatever. So to make the graph, the thing that I need is just 2 points, because I know that this is a straight line, right? None of the variable H or S are dividing, or any of them are, or neither of them are with like a square or something like that. So that's why I know that with 2 points is enough. Which 2 points I'm going to use? Always the same cases. So that's mean when the number of swords that are producing there is 0, then now it's really easy to get the total amount of helmet that I can get, that is 50. And the other strain cases is when the number of helmets that is produced in that economy is 0. Then I'm going to use that expression instead of the other, and I'm going to get that value, the value of a sword, the maximum amount is 10. The same thing is the thing that I'm doing in the case of the other economy. Okay, and after that I'm going to use those points in elaborating the PPF in its economy. I'm going to introduce that in just one graph because I don't have any space here, and also because I have to compare two economies, and that is going to be an easy way of doing that. Just putting both PPF in the same graph. So here I have when the production of sword is 0, here I'm going to produce 50 units of helmet, which is here, helmet is here, sword is here. So when the production of sword is 0, helmet is 50, and vice versa, when the production of helmet is 0, I can produce 10 units of swords. That is here. So that is the PPF for this economy. And now for the other, when the number of swords is 0, I'm going to be able to produce 20 units of helmet. And when I'm not producing helmet at all, I'm going to produce 5 units of swords. That is here. So now I can compare both economy, and I'm able to see that, for sure, this economy is the best doing everything. Because when this economy is producing swords, it's going to produce more than the other economy. And when it's producing helmets, it's going to produce more than the other economy. So I already answered this section A. The next question is about the comparative advantage. Which economy has a comparative advantage in helmets, and which one has that comparative advantage in swords? The thing that we can do is the slope of this curve of each of them. That is going to give me the opportunity cost of helmet, so that the value that is lower, or the economy in which is lower, that value, we're going to say that that economy has a comparative advantage in the production of helmets. And vice versa is going to be true for the production of swords. So, how is the way of getting that slope, which is the opportunity cost of producing more, always this variable? Here's helmet. Here I give you one way of doing that. Later on I'm going to show you the other alternative. Here is just considering 2 points. That's usual, the two strain cases, 2 strain points. So it's like going from this point to this point, where I'm observing how change this value, swords, when I increase helmets. So I'm going to see the effect of producing more helmets. The strain values, as usual, are, well, the final value in the blue line, okay, of swords was 0, here, that value is 0, minus initial one is in the vertical, so it's 10, divided by the change in the production of helmet. Initial value was 0, but the final value is this point, which is 50. So you are going to do exactly the same for the other economy, okay? You are starting this point when you are producing swords, but you want to see the effect of producing helmets. So you're going from this point to this point. Keep in mind that helmet is in the horizontal, so producing more is going to the right side. Of course, you are going to go also down in the other variable, because if you want to produce more helmets, you need to produce less swords, okay? So that's why you are going to get that. In fact, you can see here that this value is smaller than this, so we can conclude that Kings has a lower opportunity cost in the production of helmets, so that economy is the one that is going to specialize its production in helmets, while the other economy is going to produce swords. Nevertheless, we are going to see a different way of getting the slope of these curves, but instead of using just 2 points, using how this variable is connected with this variable, and how does it change this when this increases in 1 unit using the derivative. So the right notation to do that is this one. The meaning of this is how does it change this variable when this variable increases in 1 unit. Because we want to get the slope, so how is going to change Schwartz when we increase 1 unit of helmet, we use this expression. In fact, we need to know how is the connection between Schwartz and helmet. More specifically, I want to see how this variable depends on this. And that is coming not from this expression, but for this. You can see that this variable always has to be isolated. And then I can do the derivative. To make things easier, let me show you that this can be also expressed in this term. So that is the same. I want to do the derivative of this, which is equal to this. So you can separate on one side this minus this. Okay? And also, this h, which is your variable, is the only thing that is going to change, so you can do the derivative of that. You can see that this h is like being multiplied by 1 over 5, more specifically minus 1 over 5. So if you want to do the derivative of that, is derivative of a number, 0, because it doesn't change, minus here this value, which is the one that is multiplying your variable. It's like when you are doing the derivative of 3x, it's just the number that is with the variable. Here is exactly the same, and that number is not a number higher than 1, okay? It's below 1, it's 0 point whatever. It's 1 over 5, I think it's 0.2. It doesn't matter, it's just a number, so that is the derivative. Because now in getting the slope is negative, but if we are talking about opportunity cost, the word cost is telling me negative, so I have to forget about the minus, okay? The same thing you can do for the other economy. So here you have the function that connects both variables, where you can see how this depends on the other, and then you can make that derivative in the same way as this one. So in that case, the result is the number that is with the h, with your variable, and is minus 1. So to conclude, we have that, well, you know that the slope of the absolute terms of that derivative is the opportunity cost of producing 1 unit more of, in this case, helmet. So that is also equal to the relative price of helmet, okay? The same thing is going to be for the other economy, okay? Here we have K, here we have U, so in this case is 1 over 5, as you already know, and here is 1 over 4, but in absolute terms. So that is the opportunity cost of 1 unit more of helmet. In both economy, the values are different, but also is the relative price of that good. So, of course, we have just the other relative price of the other good. So, Schwartz against helmet. And it's the inverse value. Okay, the thing that we have is the opportunity cost of producing 1 helmet in this economy is smaller than in the other economy. We should compare this value to this value, because in both cases it's the opportunity cost of producing 1 unit more of helmet. Here is smaller, so we should know, or we should say that that economy has a comparative advantage in the production of helmets, while the other economy has a comparative advantage in the production of swords. So we are going to see now in the next the next part of the whole exercise how it's going to be traded after these two. How it's going to be the consumption and production in each economy after both economies decided to trade between each other. So to get that result, we need to know what is going to be the new and unique relative price of helmet. Of course, the inverse number is going to be the new relative price and unique relative price of swords. And also we are going to see what is the starting point, so we need to have information about what was the consumption and also the production in that context in which each economy was closed. Then within the new relative prices we are going to see what is the production in each economy, what is the thing that each economy is going to produce, and we need at least just one data about the new consumption after trade openness. So now we have the new relative price of helmet, 1 over 4.5. So we have also the new relative price of shorts, which is 4.5. So this is the starting point. So I mean with that this is the moment in which each economy is producing and consuming everything that they need. So both markets are closed, and we know from the data that we have that this economy in that context is producing and then consuming 2 units of swords and 40 units of helmet. This economy is consuming and producing 3 units of swords and 8 units of helmet. Here, consumption equals production. You can consume anything that you didn't produce previously, because we don't have trade between these two economies, okay? So we also know that to get that result is because in that point, for this combination, we have 3 things that are together. One side, possibility. So this line is the PPF. In each economy, given the technology and given the amount of labor, we have a different PPF. And that is telling us about the possibility production. Also, we need to take care of the labor market. So that means where is going to be actually the production. It can be in any of these points, but we need to consider the market in the case of labor, so the labor market. We know that in a closed economy, that is going to happen when wages are equal in both sectors. So that means that the relative price curve it's equal to the opportunity cost. In fact, the relative price of helmet must be equal to the opportunity cost of helmet. In fact, we know that the slope of the PPF is the relative price of helmet. So in this case, in which the economy is closed, we know that the PPF and the relative price curve is in the same place. So we are just observing one line, but in fact there we have 2 lines. So it's like saying that each point is possible because the production factors, but also because each point can be a situation of equilibrium in the labor market. And finally, on one side it was production, in the other it was where it's going to locate the only production factor. So also it's production, and then consumption is coming from the indifferent curves. So it has to be a point which is possible in terms of production or in terms of the labor market results, but also considering how is the utility of the consumer, how they want to consume both goods. Okay, it's telling us about the preference of the consumers. And if this is the result, it's because here we have an indifferent course, and also here we are going to have an indifferent course. So the 3 things are together in this context. Now we know that these 2 economies open to international trade. This economy has, here is helmet, so this economy has a smaller relative price of helmet than this economy. So it's for producers here, they are really happy because they can export that good in exchange of other goods, okay? And in fact they can charge higher prices. It's going to be between this value or this value, and finally it's going to be that value. So we are going to have a unique relative price of helmets, and the same story is about the other good that we have in this economy, okay? So that means that the relative price curve is not going to be anymore completely over the PPF, okay? In fact, in this case, we are going to see that the new relative price is going to be with, this was the initial relative price. Now, is this one, you can observe that this value is higher than this one. So we should expect a steeper relative price. In fact, also we know that it has to touch the production possibilities, because it's joined to the fact that we can produce more than the thing that is over the PPF. So eventually we are going to have something like this. You can see that this line has a higher slope than this one. You see, as far as you are from the flat, is because the slope is higher. So in this case, the slope is the relative price curve. The new one, okay? This was for helmet, international, and this was for swords. Okay. So the opposite is going to happen in this economy because that value, it was bigger than this. So that means we are going to have, well, this value, sorry, but the whole thing, in this case, it was a small, here it's going to be a smaller. So we are going to have a smaller slope, okay? So something, for instance, like this, because always it has to touch at least in one point in the PPF, and always we are going to get that point which is possible and is the biggest one, okay? So here. In fact, this line and this line should be parallel, but in my case it's not really the fact, but they should be, okay? So here we have the same value, that new international of relative price, international relative price of helmets, okay? From here we have just the first conclusion, and that is that this economy, which is the economy with a comparative advantage in the production of helmet, when it opens its barriers to trade, is going to specialize in the production of helmets, while the other economy is going to produce just swords. Okay, that is the first conclusion that we have. So in this context, for this model, given that assumption that we have, its economy is going to produce just one good and nothing of the other good. And they are going to choose that good in which they have a comparative advantage. Now the next step is knowing what is the consumption of each economy in that good and in the other good. For doing that, we need at least two data, okay? This is the first one, the relative price, the new relative price, and at least the consumption of one good. I think we have the consumption of this economy for this good in the open context. That is the same value as in the case of closed economy. But by sure now, the consumption of the other good, it must be here. Because this new relative price is also known as the consumption possibility curve, because it's telling us about how much I can consume given international trade, which is not the same as the PPF, where it's telling us about the production, possibility of production. When the economy is closed, my consumption is over my possibility of production, but thanks to international trade, I can consume more than the units I can produce. Because, why? Because each economy is going to produce in that thing in which they are the best of doing that, at least in relative terms. Now we are going to see how we are going to get this value. So here we have the production is just this one, the consumption of that good, and we need to know which amount is going to export of this good and how much they are going to import of that good. And the same thing for the for the other economy. Here we don't have a home and foreign. Each of them has a name. Okay, so let's see that part. So as summarized, we have this information after international trade. So we know that this economy is not producing swords, just is producing just a helmet. We don't know what is the level of consumption of these goods. We know that the other economy is producing this number of swords. Yeah, it's here. Also, we know the consumption, but we don't have, oh well, it's not producing nothing of the other goods, but we don't know this value, okay? We just have that value. So, as I said, we need then to have this value. Also, we know that this is, if this is the equilibrium, then the indifferent curve must be over here, the new one. So, always is going to be something parallel to the initial one, they are never crossing between each other, and it's going to be a little bit more far away because now your consumption possibility is higher, so you are going to be happier than before. But let's see what is the other values, and this is going to be a little bit tricky. So you need to be really concentrate, and you really need to understand these two values, okay? That is the key. Just keep in mind that this is the relative price of helmet, and the meaning of that is like how many units of these variable swords that you can get per unit of helmet. And here you have just inverse. So how many units of helmet you can get per unit of swords, okay? So that is the tricky part, okay? So here we have that this economy is producing 5 units, is consuming 3, so that means that the rest is exporting to the other economy. So we know then that the other economy that is not producing any of these goods is going to consume 2 units. So here we can go, in this case, so it's going to be in the same place, okay, 2. It's the same here, okay? Okay, but we need more information of the other variables, and this is going to be the difficult part. You can start with one of them or the other, it depends in the thing that you think is easier. I think it's easier this one, okay? So here I have that this economy is exporting 2 units of swords. So that means it's like, okay, I'm exporting that and I'm going to get the other good. But how many units? I know that, let me see, this is the number of helmets, okay, I can get per unit of swords. Okay, that is the number of helmet I can get. So the consumption of helmet depends in my export, which is 2. Take care of that, it's not 3. That is the thing that you are consuming. 5 minus 3 is 2. So production minus consumption is what you are exporting. So it's 2 times, so here I need that number, 4.5, which is 9. So that means that that economy is consuming 9 units of helmet. Sorry, because it's a little bit far away from 20. It doesn't make sense, okay? It's not perfect, my God, but the logic is there, okay? So that means that this should be like steeper, flatter, sorry for that. So it's going to be here. Perfect. Now I have that the production in this economy is 5, the consumption of that good is 3, so this distance, this economy is exporting to the other economy, and because it's consuming helmets and this economy is not producing helmets, the only way of consuming something that you don't produce is because you are importing this, okay? So here we have the imports of that economy. Now we need this, okay? So let's see what can we do here. So we know that this economy is producing, let's see, this is really easy. We know the total production in that economy. We also know the number of units that is exporting. So the difference between this value and this value is going to be the consumption in that economy, okay? So it's 41.